Hello, everybody. This is the Kubernetes work group device management meeting for May 27th, 2025. We have a few things on the agenda today, so let's get going. I think, Laura, you are up first.
Hello.
Do you want to share your screen? Do I need to give you privilege?
It's just the stuff that's, well,
Okay.
yeah, I think this is okay. But I wanted to um, mention a couple of us who are working on the reliability sub part of the structured parameters cap are having a burn down meeting for like engineering, talking about the stuff that's in the reliability board in the GA swim lane. Basically, our goal is to, of course, burn all of those issues on the GA swim lane down for code freeze. Um, we I just wanted to let people know that we have this sort of standing eng meeting. I think we'll probably increase the number of meetings as we get closer to code freeze as well. The point of it is to really be able to like spend some time syncing on any PRs or issues that are blocking, make sure that we have like a shared understanding or if we can help each other. Um, maybe like a little more in depth than this meeting necessarily we'll have time to go into with all of the different stuff that's going on. If you want a direct invite to the repeating Cal invite, let me know. I didn't want to like blast everybody, but I did put a link to add it to your calendar for tomorrow, which has the Google Meet um, link that will be in. And then I just wanted to pose a question here in the subsection. Um, would something like this be helpful for other GA blockers? Like I know at the time that I wrote this 2 weeks ago, I knew that standardized attributes was like on the PowerPoint, but wasn't like super represented anywhere. But I have since seen in the Slack that Patrick has added some stuff related to that. But just like that effort or like the scale testing effort is not necessarily the emphasis of the specific group of people who first got together for this reliability meeting. So if we wanted another one or to add this to that or whatever, I just wanted to pose the question to this group and see if that would be useful for anybody who's working on those things.
Well, my impression at this point is that we don't need a separate meeting for the issues that are considered GA blockers. For those who haven't seen it, in that project board, I also created a separate view that just is basically the GA release goal swim lane. It does include a few things that are not falling under the reliability aspect. So one is the general issue that I created with tasks that are needed for the promotion to GA. I think it's all more or less under control. No big issues that need discussion, except perhaps the filter timeout in the DRA scheduler. That is in my PR as a discussion thread for GA promotion. And I don't think I have seen many comments yet on that, whether we consider that an acceptable, let's call it what it is, last minute change in the implementation and what timeout values we want. But this can be handled offline in the PR discussion or on Slack or whatever. But yeah, we do need a bit more feedback from folks.
Cool. Okay, but yeah, so so in conclusion, I guess, of my agenda point is just that for the reliability burn down in particular, we do have a sync. If you want to be involved, let me know or just show up. And there's meeting notes attached to that as well, which I'll publish in here too if anybody wants to follow in a creepy lurker way. And other than that, that's my update. Thanks.
Awesome. Thank you, Laura. And thank you, Patrick. That board looks great. Okay, Praveen.
Hey, John, can I get permission to share the screen?
Yes. Okay. Should be able to do it now. I'll stop sharing.
Okay. So, can you see what I'm presenting?
Yes.
Okay, sounds good. Hey everyone, my name is Praveen. This is the first time I'm joining this community meeting, and I wanted to bring up this topic about CPU DRA driver. I've been like talking with John, Marlo, Morton, and others about this, and wanted some early feedback on the direction in which like we can make some progress on this. So the motivation behind this is, or like the main problem that we are trying to solve here is like basically ensuring alignment between resources requested through DRA and CPU, because currently there isn't a direct way. Basically, like the kubelet resource manager and the DRA mechanism like works kind of independently, and there is nothing that ensures that like the DRA driver assigned is aligned to the CPU that the kubelet assigns. And as a part of this MVP, like the main goals are like, NUMA alignment, and also like we want the pods that need alignment to specify resource claim, but it doesn't mean that like all of the pods needs resource claim. The standard way of requesting CPU should still work, and like the resource accounting done by kubelet and the scheduler should happen like continue to work as expected. So yeah, like those are some of the main goals, and as a part of this first like proposal, uh we also want like the some of the options in the resource management, like CPU manager policy, like to not be set to static. This is mainly because like we need only one entity which is kind of has ownership of setting the CPU set C group. And yeah, like currently kubelet set CPU set C group, like when we have a static policy enabled, and with the proposal here, like the DRA driver or like the NRI would be responsible for doing that. So we want kubelet to not like modify that. Uh, and yeah, I can talk about like some of the other requirements, like as I mean, once I share more details about the proposal. So as I was saying, like this is the main this is an example topology, like node 0 is connected. I mean, node 0 is connected to NIC, and for a job that is requesting like NIC, and CPUs should get CPUs from the node where the NIC is connected to. And basically like the CPU resource slice, like the DRA driver, the CPU DRA driver would be publishing the resource slice. And this is like an example resource slice where like each CPU would be like a separate device, and it would include like some attributes like CPU ID, core ID. And the key part for ensuring alignment is like we need something in the attribute which would be like common across like all of the DRA devices. Like in this case, I've mentioned CPU, I mean the NUMA node and the affinity mask to be like the standard attributes. And there is a kept in progress, which is kind of making this proposal for like having standard attributes across DRA devices. And basically, yeah, like this is a example like CPU resource slice with affinity mask for like all of the CPUs. And this is an example resource slice for the NIC, which also has the same two like standard attributes, NUMA node and affinity mask. And for a pod that is requesting like both CPU, I mean, before that, like the resource claim for like requesting CPU and NIC, the key part here is like, yeah, like we'll have the requested number of CPUs and the NIC. And the key part is like we'll have this match attribute where we specify this one of the standard attributes, and the DRA like scheduler plugin will kind of try to align all of the resources based on this affinity mask. Uh, so yeah, like basically using this match attribute, we would be ensuring like NUMA affinity across multiple devices. Specifically coming to like the CPU part, like the main problem or like the thing that we need to ensure is like now we have like two independent entities like kind of managing CPU requests, like the standard resources that the pod currently has, which is expressed through like container resources, like the CPU request and the CPU limit. And now we are introducing like a resource claim, which is also requesting for CPUs. So the main thing that we need to ensure is like consistency in what we request through like resource claim and what we request through the standard resources, so that the CPU accounting part is managed correctly by kubelet and the kube scheduler. uh, I see a couple of hands. I can maybe I can answer them now and then talk about the rest of the things.
So I was actually putting my hand up to maybe wait till the end, but I do have a question. Well, not a question about this. This is something we've talked about in the past, even when we had classic DRA, about needing to put the resources using the standard APIs for like CPU4 and resource requests and limits alongside whatever DRA requests we made. So I think in the long term, we would want to not have to do that, but I completely understand why we would need to in this initial implementation of this.
Yeah,
The second question I had, which maybe, oh, go ahead. Yeah.
Sorry, I just want to comment on. So I think that there's so just to give some context, like this is right. We're sort of this is kind of an experimental foray into this, right? And so we want to see how it works. And there's a bunch of issues to resolve. But I think that what we're doing with extended resources, we're hoping we'd be able to extend to standard resources, and then we have to figure out like what happens if people put them in both. There's a bunch of questions around exactly what you're talking about, and so I just wanted to raise that context.
Yep. Good. And the second question I have, which maybe you're going to get to, I don't know, is how you're actually pinning the CPUs to, with like C group assignments, because CDI doesn't allow you to specify that. So do you have like an extra NRI plugin running alongside the DRA driver, or how is that
You'd
handled?
have to. You'd have to. So we had a working prototype when I was over at Intel with NRI underneath where we were doing the pinning, and it worked fine.
Okay.
And actually, Sasha we chatted about this the other day, and he was saying, well, maybe we could actually make the NRI plugin and the DRI driver the same process, right? And then you don't have to transmit.
Yeah, no, totally. We do that in other things as well. That's exactly how. And I think DRA.net does this too. That Antonio was working on.
Yes.
Yeah.
So I don't have this CPU. I just want Marlo to share that code because
it was not open, and I'm very sorry about that. We couldn't get it to be open. If it was open, I would have been using that as a jumping off point and making this a lot shorter of a process. But no, I don't always get my way.
Okay, those are my comments.
Yeah, again, like as John was saying, like we would need a POC to kind of make sure whatever the proposal is talking about works, and there are still a few like details that needs to be ironed out. Just wanted to make sure like the general direction kind of makes sense. I agree that it is currently kind of hacky that we need to express like the intent for the same resource in two places, and we also have some challenges to ensure like both of them are like kind of synchronized and things like that. But yeah, this is like the MVP proposal that currently we have to mainly ensure like NUMA alignment. And yeah, I think Marlo did mention, so the current plan, I have briefly talked about this, like the current proposal is like the DRA driver would be responsible for it has the main logic for like what CPU masks should be assigned to like what containers, and that gets plumbed to the we definitely need like a NRI plugin which actually goes and applies the CPU mask itself. like to the container C group. So that is the initial like proposal that we have. I think Francesco, you have some questions?
Yeah, but yeah. So is the presentation finished? Because I can wait till you finish to illustrate your points.
Yeah, I can. I think I've covered like most of the things. So again, like coming to the CPU accounting thing, like I did mention that like by ensuring like the standard resource and the resource claim match, like the kubelets and the scheduler's view of like how much resources are available on the node would need to match, so that it can like basically uh for pod scheduling we need to know like how much of CPU is remaining. That is the reason why like we need alignment between the two things. And also we kubelet currently has like some ways to basically like specify or reserve some CPUs on the node that needs to be plumbed through the DRA driver, so that the same CPU is not like also exposed or also exposed through the resource claim. Those are some of the things that we need to handle like in the implementation. And the other key thing that I wanted to mention is like in the current proposal, like we are not uh, trying to assign like exclusive CPUs, like pin CPUs to the container, but rather we just want to align CPUs to a specific node in the first pass. And this would also mean that like the nodes or the CPUs that are assigned to a pod that needs alignment would also be used by like other best effort pods. So there could be like more contention on like some of the NUMA nodes, because like best effort pods are assigned to the entire machine, while like the pods that need alignment are assigned to like a specific NUMA node. So that is one of the known limitation in like the first attempt at this solution, where like there could be more contention on some of the CPUs. I have talked about some long-term goals, but these are like mostly exploratory in this state. So I can stop here like for more questions.
Okay. So thank you for the presentation. So I have so many comments, so I'm trying to focus on the most important part, and so I'm very happy this is moving forward. This is something that has in a bunch of very high in a wish list of a bunch of people, myself included. But I guess the first question that I will probably ask is, what's exactly the goal of the MVP? Because you folks talk about NUMA alignment, but I'm really struggling to see the use case for NUMA alignment without pinning. So I'm trying to understand the goal for the MVP.
So I think that as an MVP, we're trying to limit scope. So I'm open to pinning or things like that personally. I assume Praveen would be too, based on our conversations. It's just, we're just trying to get something. We have originally our use case, the reason we're pushing it now, like trying to move it forward, is we have some use cases internally for our machines that have both GPU, NIC per GPU and data center NICs. And the data center NICs, we want them, we want the processes, loading models and things from from storage to be NUMA aligned with the data center NICs. But so we were trying to move that forward as quickly as possible, but I don't know, our schedule doesn't need it quite as soon as I thought. So we may be able to expand the scope a little bit from my perspective. I don't know about Marlo and other customers of this thing we're building. But
the pinning part wasn't hard, John.
Okay. So
I'm not worried about it.
Yeah. So anyway, if it's not hard to do, we can add it.
No.
This is an initial proposal, Francesco.
Yeah.
So whatever,
No,
Everybody's input is very welcome.
you know, I'm very in agreement about reducing the scope and having a minimal viable product. But you know, in this case, I'm struggling to reconcile minimal
minimal
and
is.
viable. Yeah.
Fair, what viable is. Okay. The other comment I wanted to make along these lines of like, depending on our timelines, maybe we want to start to think about it is we have the longer term, right, where we want this to evolve to is using the consumable capacity cap as well,
Okay.
right? So that we don't publish as many individual devices, but rather we publish, you know, a device that of a device representing all the CPUs that are topologically equivalent from our perspective, right? And then we just draw down on that resource. So like this is what we mean. There's a path towards like where this goes, and we're just trying to like we're just trying to learn what we can based upon the state of like one of the requirements I gave Praveen was let's do this based on things that are beta, things that are planned to go, you know, to be in beta by 134, and that's it, not anything else. And so that's part of the constraint of this design is not doing things like consumable and things like that.
I really need to make to raise a couple of other points.
Unfortunately,
so
I'm done. Yeah.
No, really, I don't want to steal the show, but I really need to raise 2 points. So the first point is still about the minimal viable product, which is I completely agree. Again, design-wise, it's the most sensible decision. What I'm concerned, and I would really like to raise attention to, is to make sure that the whatever we experiment to, which is great, is extensible for the future. And a very easy example is the affinity mask. Okay, I'm fine starting with the NUMA affinity, great. But if we pick, for example, the top level name as affinity mask, basically we are already painting ourselves in a corner because, you know, it's NUMA affinity mask, fine. NUMA/affinity mask, fine. But something that allow us to say, okay, here is a better way, better in the sense more precise, serving more use cases or whatever. That will be something that allows us to experiment and still, you know, have a clear path forward and extension path forward. This is something. And
yeah, actually, so Francesco, real quick. Well,
yeah. Go ahead, Kevin.
I was just gonna say while you're talking about the affinity mask, I'm still struggling to wrap my head around how that would even work because, at least as it's currently proposed, because the match attributes have to match exactly, not just have certain bits set within them.
That would have been my other, let's call it, low priority comments, because this seems to be a reduced form. I mean, something like topology manager, but in an our scope. So yeah, but I'm really, yeah.
Let me fill in the details there. We have a separate enhancement issue, maybe to be kept around the affinity mask. So we should make that discussion there. The idea would not be that you use that as a match attribute. So this design should show it that way.
I see where that's going. Yeah. Right.
The idea would be that if we can agree, and that's an if, that's a big if we can agree on some sort of affinity mask, then that's just one, right? Then the user doesn't have to do anything, and we can make a best effort. Every single DRA-based request across every device that publishes an affinity mask will make a best effort attempt to schedule to align the affinity. Then we'll just add one under constraints. We'll add one field that could be a Boolean that just says require affinity, and then you no longer need to do all this match attributes and understand the internal topology. You just say, if I don't do anything, I automatically get best effort alignment. If I don't want to schedule to a node, if I can't get alignment, I'd rather not schedule, then I can just tell you I'd rather not schedule if you can't get alignment. So that's kind of the direction I'm hoping to go with that, just to fill in kind of the background. So that would be not a match attribute, but that would be a separate constraint that uses a bitwise and or whatever we need to do to line up and make sure things are.
Yeah. It'd be a bit more complicated than that, but I see where you're going with it, and we can chat on the other cap about it.
Yeah, we should probably put a reference to that other cap in here.
Yeah, I think I've already linked it somewhere. I think this is the cap. So I've already linked it in the doc. I think
It's not
the
the
tips
standard device
suggest.
one, it's the bitmask one, CPU bitmask one.
Oh yeah, okay. I'll add that as well.
Okay. So yeah, makes sense. And the last point I want to raise, which I really feel I need to, which is open-ended, so I saved it for last. So the two big problems which we historically, or at least I was aware about historically facing when doing this kind of external, let's call it management, was basically accounting and ownership. Meaning that the kubelet, okay, even if you stop, disable completely the CPU manager, kubelet still owns the cgroup structure basically, because it will say, okay, this is the layout and this severely constrained the solution space. And this is actually by design, and that was reinforced in a recent Signal meeting on which we were talking the node resides on which there is a proposal to let the runtime specify the machine, and that the conversation went to the point that okay, this weakens the kubelet stance on which it owns the node. So basically, even if we completely disable the CPU manager, still kubelet wants to own, and to a certain extent very much owns the CPU structure, because even if nothing but the cgroup structure is fixed, this severely limits what you can actually do. For example, is mentioned in this very cap, the having shared an exclusive CPU. This is very hard / impossible, probably impossible to do with the current layout. So we need to figure out eventually the ownership, but the kubelet very much want to own the node. So it's a tough conversation, which I don't have a very good answer to. And likewise for accounting. Now, we can disable the node resource fit scheduler plugin. It's a scheduler profile. We can say, hey, we can disable it, and then, but still, the accounting part is something that will probably need some careful point. And yeah, I don't really have a good answer for any of those, but this is points we need to be aware of.
I can answer that if you don't mind.
Go ahead.
So summarily, what you could do is if you're running this DRA plugin on particular nodes, you can have an admission controller that translates the resources over and then have the NRI, basically the NRI driver underneath, do the placement, instead of having to have kubelet versus the other resource manager underneath. Because the way we were doing it in the past was we basically disabled CPU manager entirely and then owned to the node. So you don't want those fighting, and I agree. Does that help?
Yeah, it's a start, but
Okay.
I think I'll just say one thing. Kevin, when you have your hand up, is that stale or is that new? Okay. So Francesco, so I think the ownership issue is super interesting from my point of view. The one thing so there's ownership of between kubelet and other components like the runtime on the node, but then there's ownership between kubelet and the scheduler. So we have this same discussion like with node resize right now doesn't go, or in place pod resize doesn't go through the scheduler, right? So what happens when you don't go through the scheduler is you create race conditions wherein a pod can come in and the scheduler can assign it to that node, but it's unschedulable on the node. So we have to figure out what the protocol between the kubelet and the scheduler and the control plane is, as far as like informing or asking permission or what. Like, I think you're right. There's kind of an ownership at multiple layers here, and like from the scheduling point of view, like I just want to ensure that the information I have about the node is accurate enough that I can make a scheduling decision that's not going to be rejected. And beyond that, I don't think the scheduler needs to care, right? But I don't know if we're quite there yet in sorting out all of the details of that.
The reason why I'm raising this open point is because I would very, very, very much like this effort to progress to full fruition.
Yeah.
What I don't want is to us to create, or anyone involved to create a very nice prototype, then has to stop because we hit the wall, for example, of kubelet ownership.
Right.
So okay, hey, fine, but I'm just pretending.
No,
I'm
I
making a
love it.
scenario.
Yeah.
Like okay, fine, but you cannot really change the C group, for example, the pod C group, and then the container C group, which again limits things if you want to do mix and match, shared and exclusive,
Okay.
because the kubelet owns that. So I don't want that. I want to succeed.
Yeah, and I think Praveen brought something similar up very early on, and we're like, well, maybe there's some protocol, maybe because so DRA typically working with extended resources, kubelet didn't own those, and so it was quote easy.
Exactly.
The driver owned them, right?
Exactly.
So now maybe since there's a kubelet owns these, maybe we need an additional interface or protocol between the kubelet and the DRA/NRI piece or runtime, whatever. Like there's something more internally here, some internal negotiation of ownership or information flow that we need to make happen. I think that's to me that's a viable a path for things that already have ownership by kubelet. We can't just take ownership; it won't work, right? So we have to have some sort of communication path. So it sounds like you're super interested in this. So please get involved as much as possible and help us figure that out.
I will love to. So just comment and then shut up. Where is the in working group device channel is the place to talk about these things? We have a more focused. I'm asking.
That would be the place for now. If we eventually we're trying to create a repo in KSIGs for this driver, and that would be obviously where where GitHub issues and everything, or at least
cool
discussions with them. Okay.
Just a quick point, like as John was mentioning, we did talk about like having some sort of a mechanism between kubelet and like the NRI plugin to align on what CPUs are pinned. This was one of the reasons why, like for the first pass, we did not like want to have like exclusive CPUs pinned, but rather the NUMA node, because like currently there is no way for like the NRI plugin to tell kubelet to not assign these CPUs that are pinned to the other best effort pods. So we might end up like restricting this jobs that need exclusive CPUs to a small subset, which is also used by like other pods. So I mentioned this in the long-term section, but I would love to chat about this like more on the Slack, I guess. So yeah, that's
Sorry to interrupt, but what you're forgetting one easy piece. What for best effort and burstable containers, you can migrate them to another CPU cores, and this is very cheap operation.
Yeah, I agree, but like we still need to prevent the best effort container from using the CPUs that are pinned to like a higher or like a guaranteed container. So that was the problem that we still need a solution for. Like we still need some sort of communication.
So I want to pause here. We have two more hands, and we've got other topics. So Dominic and Swati, I don't know who's it first, but if you guys can make it short, then we can move on. Sorry, Praveen, but I think we've taken quite a bit of time. It's a super interesting list.
Okay, Swati, you can go ahead.
Thank you. So my question is related to something that we've historically spoken as well, in addition to accounting and the C group structure, bootstrapping. The fact that CPU-based DRA plugin is going to be an infrastructure pod, we need to be kind of conscious of the fact that the order in which the pods are deployed matter, especially when it comes to node reboot scenarios. We've had this pain when it comes to device plugin. So I think it's something that we as a community need to be conscious about when it comes to a CPU-based DRA plugin, especially when CPU is a core resource. So I just want to point that out. And we've kind of had brief discussions about possible workarounds and ways around it, but I don't think we've had explicit discussion on how we can solve this as a community. So I would, I think, encourage us to kind of keep that in mind.
Thank you.
Okay, so I wanted to raise two things from the scheduling perspective. So obviously to make them use of this mechanism, we probably should have scoring that allows scheduler to select the placement that is more optimal considering the NUMA nodes. So this is something that we are probably all aware of. But I'm wondering whether is there a case in which the scheduling should be affected by scheduling of two different pods could be affected by a NUMA node. So whether one pod should end up on, if they end up on the same machine, whether they should end up on the same NUMA nodes as well. I, of course, imagine that it's not MVP, but is it a case for a long term?
I don't think, I haven't heard any requirements for that. The requirements I've heard are more narrow. I imagine it's possible, but we can maybe raise that as a question.
This also is related to the point, to another point which I was trying to avoid, which is who decides the final allocation? Is it going to be the DRA controller saying, okay, all of this is going to land on NUMA node 0 versus, okay, let's go kubelet figure? Because the two-step allocation was pretty much not a bug, but a design feature, as far as I recollect. So this is another point related to that. I don't want to jump on that now, but it's related and it's coming.
Praveen, if you can take notes of Swati and Dominic's points, maybe we can we can move on since they're just.
Yeah, I have taken some notes down.
Awesome, thank you. Okay, let's move on to the next item. Thank you. That's a great topic. The next item is Jack.
Apologies in advance. This will not be as interesting as the previous topic, but I wanted to bring up, so context here is scalability tests. SIG Scalability runs a bunch of test scenarios regularly that are release informing. I'm not aware if they're release blocking, but we can set that aside for now. Important tests that validate Kubernetes at scale operationally. Alay, I'm not sure if Alay's on the call, but I'll call him out here. He is driving for some DRA native SIG scalability tests, so that's fantastic. So this will include building a cluster at scale with DRA enabled and running through a battery of sort of canonical DRA scheduling scenarios. And then we'll have some cloud providers can have SLAs that come out of that for their DRA customers. I'm curious about sort of proactively testing the 134 scenario before 134 drops, which is to say DRA is enabled by default and you're not using DRA, but there are now new code paths available to various components in your Kubernetes cluster to do normal, quote unquote, normal scheduling. Do we have an owner for that? I'd be happy to drive, we could put together a test on Azure. We've got some SIG scalability tests there that would just essentially, we could A/B what is a common SIG scalability scenario look like DRA enabled versus not.
So I think that with the GA flip, right, it's going to be on by default. So
yes.
Our ordinary scale test should exercise that. I mean,
yes.
I'm always happy to get more scale testing resources if you've got them. And if there's a specific test you want to do, I mean, I'm personally, I think that's awesome. But we should be exercising the ordinary path without any DRA automatically just by the fact that it's on by default.
Yeah, and there's one more thing to add. As part of the work for DRA, there is one metadata work, which is to enable this flag. Now that DRA is in beta, enable it on by default, the feature get on by default in all the 6-scale tests. So as soon as this work merges, we'll have 2 sets of tests. One, the regular 6-scale test, which is currently being executed with feature flag on, and then additional DRA related tests. Obviously, the feature flag will be on for both of them. And you have a comparison. So then we could compare that the current 6-scale test regressed or went up in feature, or whatever the comparison is, with right now they are running as feature flags disabled, right? So we'll be able to get that data before GA once this test merge.
But are you driving that part, LA, the part where we flip the feature flag on all the existing
Yeah.
6? Okay,
yeah,
great.
It should be part of that.
But Jack, if you want to do like an early test of that, like the sooner we know of any trouble, like the more time we have to fix
We'll
it.
We'll do that this week.
Awesome.
We'll get
That
one
would
data
be
point
awesome.
this week.
Yeah.
Okay. Yeah, no, I'm concerned about doing it well in advance of 134, not wait
Exactly.
for
We don't want
134
to come down like 3 weeks from code freeze and be like, oh crap, it's really broken. Yeah.
Just to add more, I am close to the point where I have the workloads for the DRA test ready. I'm just collecting all the observations that we need for metrics, and once that is there, I'm targeting to put that PR up for review. So the long story short, I'm not expecting going all the way to 134 before this DRA tests will be merged. We will have it pretty soon.
Awesome. Thank you. Antonio?
I just found the link in the notes are the tests that we are running.
That link is to Alay's in progress branch for landing new DRA functional tests in 6 scalability.
Okay, I want to check to see what we are testing. Just that. I will.
Yeah, so that's going to have like perf tests, new foo that moves cluster loader 2 scenarios forward, that kind of thing.
Great, thank you.
Awesome, thank you. All right, next, Geeta.
Right, I had a quick question about the number of devices in a resource slice. For our devices, we have something called a neuron core. It can be thought of as a partition. We have 128 of those, and they go into set of devices. So the current limit gets in the way of publishing all of them into a single resource slice. Now we could work around that by publishing them into multiple resource slices, potentially. But I wanted to bring it up and ask, how do we think about this limit? Is this a number that was agreed upon as part of the first release? Is it flexible? Can it be increased?
So, go ahead, Martin.
Yeah, so we have similar issues at Google where we're very close to the current device limit. It seems like if you're relying on like the professional devices, then currently splitting it across multiple resource slices doesn't work because we don't allow cross resource references. There is an issue. I'll paste in the link where we have a discussion around whether we should enforce those limits across pools instead of resource slices. And if you have concrete use cases, please provide them there, and we can figure out if we want to do it. It's been a little bit back and forth, and we were looking for good reasons to really do it.
Yeah, so just context, just to make sure folks understand. So there's there's a number of different, so resource slice itself has a limit on number of devices. But resource slice is just a view of a partial view of a single pool. So the resource pool, every slice has a pool name, and the driver of the pool name, and then a count of how many slices are in that pool, so that when the scheduler looks at the whole thing, it can allocate a generation number. So that it can sort of look and say, I've got all the slices of this generation, and so therefore I can proceed. So I have a complete view of the pool, so I can proceed with scheduling. So that's how we divide up. And because of the etcd size limits for objects, we can't just dump them all in one object. So we have to sort of shard them out across a bunch of different resource slices, that whole pool. That works fine for ordinary devices that are sort of independent. But then we have our KEP for partitionable devices. And with partitionable devices, there's some shared resources that are shared amongst devices. And right now, those shared resources, counters we call them, those and mixins, those shared things are only defined on a per slice basis. So if you are using the partitionable functionality to account for overlapping devices, so that like you take one device and other devices go away, then you can only do that for devices that live in the same slice, even though conceptually or logically it shouldn't matter, they're all the same pool. Like, so we have a proposal that we could make those mixins and those counters pool wide rather than slice wide, and then you kind of loosen the constraint, and so splitting it across multiple slices, there's no functional difference. It's just a way we allocate, or the way we shard. That does have a cost, right? Your validation is no longer on a slice. Your validation is now across the pool, which means that it can no longer be done at emission time. It has to be done in a controller. And so that's the debate. Anybody who's interested, please jump in and help contribute.
Perfect. So that is exactly the question I wanted to ask. And if we could make those limits at a resource pool level, that will definitely help. We will join the debate on the issue. Thank you.
Thank you, Gita. Okay, let's see. I think I'm the last agenda item, and we have more time than I expected. So if people want to go back to the other topic, we can. So all I wanted to do, we have this document, the slide that we've seen here before. If we can get, I don't know, a Ruhi's GitHub handle put in here instead of name, just so we can more easily associate. But in any case, each person on this list, please go in to your go into the KEP. It's just linked right here. Make sure that that you're assigned on GitHub to that the KEP has been lead opted in by the owning SIG, so the owner's on that slide too, and that it's added to the 134 milestone. If we have these two things done, then it'll show up in our board, and we'll make sure we don't lose track of it, because the slide's not going to be the right place, right? We're going to track it on the board. I also want you to go in and make sure that you talk. There's usually multiple approving SIGs as well as the owning SIG. Go to the meeting for the SIG. It's either most of them are scheduling a node, but some are off. And go and just make sure, because if the owning SIG opts in, but another approving SIG doesn't have it on their radar, they may not have the bandwidth to review your KEP. So please just go to them, make sure they're aware of it, ping them on Slack or go to their meeting. And then the other thing I wanted to highlight is enhancements freeze is June 20th, but the production readiness freeze, which I had hoped they were going to rename to something else, but essentially by June 12th, you have to have a PR in, or this cycle we're not going to approve your KEP. Basically, we're not saying you have to have it done, but we got to have enough meat in there. Otherwise, what ends up happening is literally the last 2 days, we get new KEPs created, we get new, and it becomes very difficult for us to get them all in. So you don't have to have it done, but you have to have it kind of in the review process. Your PRR questions have to be filled out. If the PRR is opened after June 12th for your KEP, then it won't be in this cycle. So please have your PR open and ready and in progress.
One other thing, if you create PRs, add the working group device management as a label. So /WG structured, not structured parameters, it's as a structured logging. That's the other working group. No, device management. That makes it show up on our working group board. The lead opted in and milestone, that's for release, SIG release. But we also do have our own board, and we have KEPs show up there, but only if you manually add that label. Otherwise, it might not show up.
Great point, Patrick. Thank you. Okay. All right. Well, I guess I cut off our debate on CPU too soon because we have 5 minutes left. Are there any other topics or things people want to address, or shall we just give ourselves 5 minutes in our day?
Perhaps, I don't know, we're not going to resolve it here, but there has been quite a bit of debate on the extended resources cap. I think Dominique has an alternative idea that he would like to see explored. To be honest, I'm not a fan. I just don't see that it actually simplifies anything, and it has to have additional complications. But we are currently at the point where Dominic is not happy with just exploring or just elaborating on what we plan to do. He wants more eyes and more investigations on some alternative approach. So that's where we are with that one. Yeah.
Yeah, thanks for raising that. Yeah, I did see those comments, and I think it makes sense to explore the other option. I'm aligned with you, Patrick, but like it's certainly healthy to have the debate. And so I'll talk to you. I don't know if he's on the call, but he can maybe take a little time and investigate that.
The problem is that it basically, for a fair comparison, it pretty much has to be a complete KEP, including the entire design, entire API change that would be needed for this alternative proposal. Otherwise, we are comparing a concrete proposal where we know what the problems are against something that's at this point a bit hypothetical, because we haven't even really talked about what that pre-created resource claim really would look like and what all the corner cases are. So right now it's a bit hard to compare.
Right. I think my last comment is also pretty important. I mean, it was in reply to your comment, because you pointed out what was the goal. So I think it's also interesting to decide how it should look like from the user perspective. So which option is better to see a resource claim that is maybe optionally allocated or not, versus having a claim that is allocated to something sometimes, but sometimes it's not. So from user perspective, it might be probably better to see the resource claim, the generated one.
I don't know. Like you would see the resource claim even if you're not running DRA, right? Like you're only running device plugins, and that might be a little confusing. Eventually, though, you'll see the I don't know that they're both a little all right. They're both a little awkward, right? No matter what. So, like Patrick's argument that, like, if you think of the resource claim, there's two sets of intent there, right? There's two purposes. One is the intent, the user intent, and one is to capture the record the allocation, right?
Of course.
That's where the user intent's already been expressed, but we do need a way to record the allocation. So
of course, like what we are like trying to develop the scheduler into the direction of supporting workloads, and having like dynamically constructed scheduling constraints as an input to scheduling is important. And scheduling itself should not generate those scheduling constraints. It should follow them. So if we look from the perspective how you understand scheduling, it would be better to have even this resource claim, the optional one, to be explicitly specified as on input, not
But it's redundant. It doesn't actually add any additional constraints, does it?
No, because
it just represents what already is the input to the scheduler, which is the extended resources.
Yes, but well, why internally this is a resource claim which gets allocated through the DRA driver. You could say that it's implicit and
no, it gets allocated by the scheduler.
So no, but yeah, of course, by the plugin.
Yeah, this is too big of a topic in the 1 minute we have left.
Yeah,
clearly. Let's continue the discussion on the cap, and we'll see where we go. Okay, thank you, everybody. Have a great day.
Thank you.